We had a very last minute change in the schedule. And what we did was we replaced one of the speakers to make it with impromptu lightning talks. So these are all people that I asked.
2017.
Okay, 2017 is the launch. Yeah, and the students actually had a poster up earlier about the ground station too. If you had a chance to see that, but I'm sure you could ask them about it. Okay, so I was just saying the following talks are all people that I asked after, like around lunch to give a talk. So there'll be a couple minutes, very impromptu, and I don't think Seth even has slides, which is totally fine. And Seth is actually, I'm going to call you the deputy working group leader of the GNU Ready Companion Working Group, and that's what he's going to talk about.
Alright, so I'm just going to lightning talk. I don't have any slides, so really the point of this is to show off some of the new features that we have in GRC that you may have not seen, you may have heard of. A lot of them are really useful, so I'm just going to jump right in. So let me see if I can get the right. So one of the new features that we've added, if you look at the poster, these are actually shown. And the text on this is really small, and I have no idea why. I just updated it. It's crazy. Anyway, so one of the new cool features that we've added is under the documentation, advanced tab, is this comment block. So it's really cool that you can just come in here and essentially type anything. I don't know, there's a bunch of crazy stuff. And what ends up happening is it pops up down here. I don't know if you guys can see that right here. So it actually shows up right below the block, and if you're trying to add some sort of documentation to your flow graph and kind of point out what's going on, it's a really useful feature. Also, there under the View tab, there's this new feature called Generating Code Preview. And if you go under the block again, you can go under Generating Code, and this shows all of the code that's actually going to be generated in the Python for the flow graph, specifically for this block. So if you need to see how it's setting properties or whatever, this is a really easy way just to look at everything that's going on with that block in the Python. My favorite feature, which was actually suggested by one of my colleagues at Tech, is this new bypass feature. So I have this really simple demo. So I just have 3 signals here, all being added together, and you have, simple Qt plots here. So for example, maybe you're demonstrating something to a class, or you're trying to figure out what's going on with the block. If you have a block with your flow graph that is a one-to-one block that has one input, one output, and those inputs are of the same type, normally to do anything you'd have to hit disable, and you'd have to draw a connection around it in order to use it. Well now, in the 3.7.8 release, all you have to do is hit B, and it bypasses the block, and it turns like this yellowish color. So actually, whenever you generate the flow graph, you can, so down here, let's see. Right here you can see where there's a high pass filter, but I've already bypassed the low pass filter. So if I re-enable it and generate it, you can actually see in the code, you have both of them. And the bypass feature actually will completely disable the block, remove it out of the flow graph so that when you run it, you can actually see the difference in the flow graph. So it actually completely takes it out of the flow graph without you having to do anything about the bypassing it. So those are 3 of the big ones that three of the big features that we've had in the new version of GRC. I also wanted to pull up, so I wanted to also pull up some of the features that are kind of being worked on at the moment. And hopefully we'll be able to get these in rather soon. So I'm sure one of the things that may be really annoying is if you have a ton of blocks like this and you have to change everything, every parameter within the variable. You have to open up the block and you have to edit it, close the block. Well, and one of the new features we're doing is this variable editor, so you can actually pop this up And it shows all the different variables, all the different names, and you can sit here and add a bunch of stuff. And easily change the variables, and eventually we'll get some, this is all still a work in progress, so it can probably change a little, but if you have, flow graphs that look like balanced flow graphs where you have 200,000 blocks and all your variables are hidden, that's going to be really easy because, like, for example, you have blocks hidden under here, and then the variable editor will be able to show all of them at once, and you don't have to worry about trying to find all that kind of stuff. Let's see here. All right, so one of the other things that I wanted to show, and for people who may be interested in getting into the current GRC development, one of the things that Tom has added in the past is theming. So if I pull up the top block, you can see this is the default Qt. Actually, the new one's the dark theme, so I can go in here and switch it. And this file is actually under the home directory under, I think, .new radio config. And you just set this Qt, or this QSS value should already be set. So when you run it, it completely changes the look and feel. So that's the dark one, which is really difficult to see on the screen. So something else that I've been working on, are kind of messing around with these different themes. And with Qt, you can do some really cool stuff. So one of the things I'm going to eventually do is make a theme that makes Qt look like WX so people can't complain about WX. So this is hard to see, but this has actually got a really cool blow on it that's kind of based off of the Google material design. Again, still a work in progress, but if you want to get involved in GRC development, this is a really easy place to go. The themes look very similar to CSS, so I'll go ahead and pull up one of them right here. So it's very similar to CSS code. It's the same basic structure, the same basic properties, with a few little differences to support the Qt stuff. And the last thing I want to show is the Qt port. It's really rough right now, still a work in progress, but I'll give you kind of a quick demo of what it's going to, some of the features that we're going to be able to add. So this is, like I said, it's a really rough version, but one of the cool things is this ability to do docking. So that we'll be able to have different plugins and you can just move them around and kind of arrange your GRC however you want. Another thing that I've seen, it's gonna zoom features, like you can zoom this in and out again. It's really rough, but that's some of the stuff that will be in the new version. So that's all I had, just a really quick demo of some of the stuff we've got in GRC, and I hope you guys like the new features and use them because they're awesome.
So are you planning to keep the WX GUI blocks and just have them actually be Qt in the background and see if it
And we can make Qt whatever, so.
Are there any questions? Time frame for which feature? Any feature?
For the Qt port, it'll probably be 3.7 to 8, maybe later, I'm not sure. That one's got a lot of work to do. For the variable editor and some other things like remote execution, hopefully those will be coming soon.
So you didn't try remote execution,
I can't get it to work right
Yeah. But it's, for example, if you're working on an embedded device, it's very useful. You just tell GRC, like, I want this flow graph to be executed with my eFude. That's what it does. And I guess all these things will be available even faster if people step in and help, volunteer to write code. And we're hoping to build a GNU companion working group. Okay, while I was setting up Moritz, so Moritz was actually one of the original lineup. One of the original speaker lineup, and then a while back we gave up our slot. So we had a couple of slots, and we thought someone else would give a good presentation, and we don't regret that because we had some pretty good stuff. But now all of a sudden he's asked to do his talk, and of course we didn't have any slides. We didn't bring the hardware that we needed to show off the stuff. So this is sort of a hacked up impromptu version of what we originally were going to show. Is your microphone?
Test.
Okay.
All right, can you hear me? So yeah, basically you've seen a lot of elaborate stuff so far. People doing pretty cool stuff with usurps, and lots of my colleagues got to spend time on building Archrock and all those cool demos. So this is more like what Martin and me did like Friday afternoon after we had our weekly beer. So it's kind of like how far can we get taking off all our education we got from the university that tells you to simulate, read standards, and try to understand things. This is more like we just go ahead and see where we go. So, what the fuck is DEC? Does anyone still remember those? It seems like around here everyone has cell phones. Turns out, like in Europe, they're still kind of a big deal. Like McDonald's use them. They actually, people do use those. Disclaimer is like, we had no idea what we were doing. We just kind of sat down and dragged some blocks together and saw how far we could get. So DEC is like this European standard that then at one point came to the US and they renamed it DEC 6.0 because they were afraid that people would think it's not cool if it has a smaller number. So they added like 6.0. So it's like 10 channels of like 1.7 to 8 megahertz TDMA. Nothing fancy, most of it actually is that. And Martin and me decided, let's build a duct tape receiver thing. Let's just try to build the simplest thing that could possibly work. And it turns out we need to channelize, as we have 10 channels, so that's what we did with the polyphase channelizer. Most of this project was actually spent on trying to figure out how those channels map to the actual channels. So we took 11 and made it kind of convenient. We resampled them, and I can show you later the goal graph. It's pretty much channelizer and then a block that we call DEC smarts that just correlates. I'll skip all of this because yeah, it's not that smart. So you have DEC first. There's several. We just looked at the one. It's like 424 bits. And has this sync field in the beginning, and we're just constantly correlating in parallel in all channels for this sync field, and it turns out it kind of works. So we use an S field, we slide off that, and then there's what they call an A field, and that has some sort of headers, but that requires reading the standard. We didn't want to do that. So we kind of read as far as, oh, there's a CRC, so that's probably the thing you want to be looking at to figure out if you're doing it right. So then to calculate that CRC, Boost has something that does that, so we use that, and we figure out the polynomials by reading the standard. We compile and run, and then, yeah, I mean, kind of, right? I mean, that can't be random. That's okay. Then you go back and read, and then you know.
I would think so.
So after we figured that one out, we're like, wow, that's pretty cool for like an afternoon of
One bit
just
change.
dragging blocks
And what's
together
that?
and using
Security.
P200 and
Cybersecurity.
running it, right? So like, we demanipulate stuff with the radio. We have minimal effort of actually reading how stuff works. Here you can see a base station from Siemens and some other stuff like that. And yeah, we get pretty far in a short time, but then that's not really useful. So I decided to go ahead with, I mean, there's other people that have done that. This is nothing new, right? There was the Detected project, and they took this like really old hardware using PCM-CIA or someone, and they hacked up the firmware and wrote the kernel driver and made a whole bunch of things. things to create an actual deck transceiver. So thought maybe we can reuse some of that. So turns out they also wrote the wire short dissector for the whole thing. So they're pretty smart. So I figured if I can trick Wireshark into eating what I'm receiving, then I'm pretty much done, right? So that's what I did. I wrote a Python file that is very horrible and wraps it in Ethernet packets in a way that Wireshark thinks that they come from their firmware. And there, I fixed it, right? So the code is on GitHub, and maybe I can even demo a bit to prove that it actually works. Assuming I can operate on Mac. This is our flow graph. So it's basically channelizer and a whole bunch of correlators, and then I feed that into a pipe, and then Wireshark can read that. Nothing happened. We'll grab something. So this is a recorded file. Basically, I recorded with a P200 at the office, my Siemens base station. So if I run that, hopefully, that's what you get. Look at that. Those are empty. I can fill them. If you look at the A field, that one didn't work. That's pretty much everything I have. Sorry?
That's the thing with beer. So.
It's so bad. Alright. Who's an expert?
Plug-in my machine. So basically, this will be the last talk. For the closing remarks by Tom. What do you think we do? Oh. Hmm? You? I'm wrong table. Yeah, so this is a topic that is very, very dear to my heart. Something that is very much not talked about a lot, not enough in my opinion. And yeah, it's something that's a lot of use of the time that we now have. So yeah, opening developed with SDR. Where does it even come from? So yeah, I have a PhD from KIT Germany, and the way it works in Germany with the PhD exams is like you go into a room and there's the professor, and they will give you a beer bottle and a random object which they won't tell you about beforehand, and you have to open the beer bottle without breaking the glass. So that's pretty much how it works. And that's why we have so many mechanical engineers in Germany, right? Because they have an advantage, right? What does this have to do with radio? So when I was young, and in Germany, drinking age is much lower, so this is a while back. People started using lighters because they could never find that beer bottle openers. But then smoking got sort of more and more banned. But on the other hand, we had the Nokia 3510. Does anyone remember that? Yeah. So, which turned out to be really good. You know, it's indestructible. You could open any kind of beer bottle. So by the way, that PhD exam, if I had taken it to the US, I would have failed because I was unable to buy beer in the coffee break. I just couldn't find any. If this were Berlin, it would have taken me 10 seconds. So all I could actually find were American drinks. We have, so, I hope I'm not getting embarrassed myself here. And I also couldn't find a 35 cent, but I found something that was pretty close. So here we have a little shortwave radio. Now basically the way it works, it's really not that hard. People, so I was surprised that I could even impress anyone with this. I don't know if this actually works. So you take the phone, you take the ball, and then you go ahead and open it. There you go. Does anyone want a tantrum? Can you just pick it up? There you go. Yeah, so, but then along came software radio, and, we have software, so how do we open beer bottles with software? The beer, or BBO as we call it in the beer bottle opening community, slightly concerned, but Matt Ennis actually saved the whole scene. I don't know if you actually realize that, how important this was to us. So the user 1, the user 2 actually came in a pretty solid case, so you could do the same thing. I don't have one right here. Same actually with all the future devices that we've brought out, and yeah. So I'm just going to sort of give you a little brief technical overview of how this works. Basically, it's really easy. You just need something to lever off, and you need a lever. That's opening a beer bottle in a nutshell. So besides of U-serves, you can use, so yardsticks are actually fun because there's some little party tricks you can do. The piece of paper is sort of considered the most difficult. But someone challenged me to use a napkin recently. I haven't tried that yet. I wouldn't even know where to start.
I find myself
yeah, but just a sort of demo. Yeah, actually I'm going to show it. So my keyring, I have a V205 PCB, and that's actually pretty good. Really, oh, sorry, V200 mini PCB.
Yeah, come on. Get it right.
Sorry. So there's multiple ways you can do it. So you can just go like this. You can also go like this, but I don't recommend it because you'll probably strip off the components, and we have sensitive balance. But this is just the empty PCB, so not a problem. But if it's populated, you can still go the sideway route. You can't do it infinite number of times because so I've done this quite often with this PCB. So I'll just have to go the sideway route. So someone want to spread? I'm gonna leave it there. So yeah, a couple of facts that are very, very important if you want to do this. Careful with PCBs, you'll rip off the balance. Don't use the connectors, use your SMA connectors. So we try and make the connections as sturdy as we can. This wasn't something that was spec'd in from the beginning, which was a big mistake in my opinion, but kind of everything. If you care about the paint, the coating, don't do this. It'll actually scratch it. If you have an opera clock, that's difficult. But if you have an opera clock with the angle bracket, so you can put it in the rack mount, those actually work pretty well. So I actually have my own advice. I ignored it opening non-alcoholic beverages. You can see it works fine as well. It's obviously considered a lesser art in the and my personal favorite SDR is the E300. It's like the perfect form factor. It's just like these as I said, you will be able to rip off the components. Do we have the E300 right here? Oh, there we go. Embedded devices, fantastic. I'll tell you. So there we go. Go back to mine.
Also, you might want to mention that twist off makes it actually harder.
Yeah. So here, again, in slow motion. There we go. Here we go. So I do think this should have been the keynote, but I'm glad we were able to squeeze it in last minute, and thank you very much. Okay, this was actually the last talk. Tom will close it up now. There's the hacker story. I'm sure Tom will talk about this, and
iPhone that you really should have brought extra like beer so I could at least, drown my sorrows and try to. Martin, you've been in the US for how many months now? You still can't find beer. I'm just going to have something back to you because this is a very important part of the conference is to thank our sponsors. Whenever I went to conferences before and I heard the spiel of, thanks to our sponsors, blah, 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 I thought it was kind of boring as an audience member, but they really do make this thing work. So really, I think it's important to make sure that they get as much airtime and thanks from us as possible. I want to thank the staff as well for putting this together. Again, this is I think you can see this is a pretty big crowd here, big building. We got all the stuff going on with the sponsors, the demos, the posters, the presentations, the food, the banquet, all that stuff. It doesn't happen without our support, our staff basically, which is myself, Tom Rondo, but more importantly, we have Ben Hilburn, Martin Braun, Jonathan Corrigan, Michael Deakins on the steering committee. Michael, would you please stand up? I really want to give him a huge round of applause for